Hi friends, in this video I will be reviewing my 13,000 mAh power bank. This is from Ambrane. I've been using this power bank for almost 2 years now. It has got two USB outs. One is regular 1 ampere out and the other one is 2.1 amperes, and it has one charging port and one LED. And for the review purpose I will be using this particular device. This is basically a USB meter which measures the voltage and the ampere, the time and the mAh output from any given charger. So this right now is empty. uh, I'll show you that here. As you can see, I've connected this to my phone and the LED is blinking. That means it's almost drained out, so it'll take like 10-12 seconds to completely shut down. You'll notice once the LED is down, see, the LED is down, it means it's completely empty. Now for the review purpose I will be charging this power bank from 0 to its 100%, and the maximum input that this power bank can take is around 2 amperes. So I'll be using my 2 ampere charger, and I'll connect this to and I'll connect this device here and the cable here, and that way any current going from this device will be measured on this particular screen. So as you can see, this has started charging. Right now it's around 1.5 amperes, and it will increase. It will go up to 2 amperes. It already has gone up to like 2 amperes, and it will continue to be at 2 amperes. Wait, it has a few readings. Let me just reset it. Okay, now I've reset it. It has 0 timing and 0 mAh right now, and from here it will start calculating how much milliampere hours of charge is going into this power bank. I'll probably not run the video for the whole duration of this charging, because this will take around 6-7 hours. I'll try and take some pictures in between, but at the end I'll once it stops charging, I'll show you the final output which this device has and the time it took, and it will give you an idea what is its actual capacity, what is the actual capacity of the power bank. It's been a little over an hour. We have a second light here and we have 2800 mAh on the meter. After almost 2 hours we are just a little over 5000 mAh and we are still on the second light. After around 3 hours we have 7600 mAh still going at around 2 ampere, and we still have 2 lights on. After around 4 hours we have 9705 mAh total discharge into the power bank. It's still going at around 2 amperes and we have 3 lights on. And 5 hours into the charging we have 12,000 mAh on the meter. The current has come down to 1.7 amperes, and on the power bank we have 3 LEDs on. After around 6 hours of charging we have around 14,000 mAh of current drawn, and the charging rate has come down to about 1.3 ampere. After around 7 hours of charging we have 15,000 mAh on the meter, and the current has come down to about 0.7 amperes. So finally, after 8.5 hours, the charging has stopped. You can see all 4 lights are well lit and the input current has come down to 0 amperes. Now if you see the reading here, you will be able to see that the actual amount of current that it shows is 15,800 mAh, but the power bank itself is rated for 13,000 mAh only. Well, there are two reasons for this inaccuracy. First is the meter itself. The USB meter itself is not very accurate. If you will measure the output voltage of most of the adapters, you will see the output voltage is mostly around 5 volts, but you can see here it shows up to 5.25 volts. And if you see a lot of videos also, they'll tell you that there is a 5% accuracy difference on this meter. So if we consider that 5% of accuracy, we can take 5% of this 15,800, which is roughly around 800. So we can assume the actual amount of mAh that went in is 15,000 only. Now again, the 15,000 still does not correspond to the 13,000 value of the power bank. That is because The power bank itself has integrated circuit which reduces the voltage from 5 volt to about 4.2 volts. So in order to calculate the efficiency of the internal circuit, we just divide 15,000 by 13,000, which is roughly around 87%. And we can say easily assume that if even if the charging circuit inside has an 85% efficiency, the power bank itself is actually carrying 13,000 mAh worth of rated lithium ions inside. Now I will use my power bank to charge my various phones, and I'll use this meter on the power bank to measure what kind of output value I get, and I'll get back to you with the results. Now the power bank has drained completely after around 13 hours. As you can see here, it has come down to the final blinking LED, and that too stopped in a couple of seconds. And if we look at the meter side here, you can see that it's been around 13 hours and the total output has been 9700 approximately mAh. And even if I connect my phone to it, the power bank dies in like couple of seconds. There you go. Now the total capacity that you see on this meter is 9600 or 9700 mAh, but the total rated capacity of the power bank itself is 13,000. The difference is because the 13,000 rated capacity is of their cells, and their cells, they operate at the voltages between 3 to 4.2 volts. 4.2 volts being at their highest capacity and 3 at their cutoff voltage. Now, even if we consider 3.7 as their average voltage, the 13,000 mAh capacity at 3.7 volts still corresponds to only 9600 mAh at 5 volts. So according to that, it's been like 100% conversion rate of the step up converter. But as I said earlier, this meter itself has like around 5% inaccuracy. So if we take that in mind, the efficiency of the step up board inside, which steps up the voltage from the cells to steady 5 volts, is around 95%. That is very good. So I believe this power bank delivers what it says. Now in my experience, I've been using this power bank for 2 years, and even if you keep this power bank just laying there for like a month or something, you still get 90-95% of juice whatever you put in to the power bank. It does not have too much self discharging rate. I hope this information was helpful to you guys. Thanks for watching this video. Have a good day.